The battlefield has just changed forever. A new era of warfare is no longer approaching, it has already arrived. Israel's revolutionary Iron Beam laser defense system is redefining how nations protect themselves from modern threats, using nothing but concentrated beams of light to destroy drones, rockets, and mortar shells in midair. This is not science fiction. This is not a future concept. This is real operational technology, and it may shape the course of military defense for decades to come. Hello everyone, and welcome back to the channel. Today, we're diving deep into one of the most astonishing breakthroughs in modern military technology, Israel's Iron Beam laser defense system. Imagine a weapon that doesn't rely on missiles, explosives, or ammunition stockpiles. A system that fires silently, travels at the speed of light, and neutralizes threats in seconds with pinpoint precision. That is exactly what Iron Beam represents, and recent demonstrations have left defense analysts around the world stunned. In controlled tests and real-world evaluations, Iron Beam has successfully tracked, targeted, and destroyed incoming drones, rockets, and projectiles while they were still airborne. The speed, accuracy, and efficiency of this system have captured global attention not only because of its technological sophistication, but because of what it represents, a fundamental shift in how air defense is conducted. Unlike traditional missile-based interception systems, which can cost tens of thousands of dollars per shot, Iron Beam operates at a fraction of that cost, using electricity rather than expensive interceptors. In this video, we'll break down everything you need to know about this game-changing defense system. We'll explore how Iron Beam works, why it matters, the science behind the technology, and how it fits into Israel's broader defense strategy. We'll also examine the economic, strategic, and geopolitical implications of laser-based warfare, and whether this breakthrough could trigger a global shift toward directed energy weapons. If you've ever wondered how close we truly are to laser weapons becoming a standard part of modern defense, the answer is clear: we're already there, and Iron Beam is leading the charge. To fully understand the significance of Iron Beam, we need to examine the reality Israel has faced for decades. Geographically small and strategically exposed, Israel has long existed under the constant threat of rocket fire, drone attacks, and mortar bombardments launched from neighboring territories. These threats are often inexpensive to produce, easy to deploy, and designed to overwhelm defensive systems through sheer volume rather than precision. For years, Israel's primary shield against these attacks has been the Iron Dome, a highly effective missile defense system capable of intercepting short-range rockets and artillery shells. Iron Dome has saved countless lives and prevented massive destruction, but its success comes at a steep price. Each interceptor missile can cost anywhere from $40,000 to well over $100,000, while the rockets it destroys often cost only a few $100s to manufacture. This imbalance has created a critical challenge. In prolonged conflicts, the cost of defense can quickly exceed the cost of offense. When adversaries launch large barrages of cheap rockets, even the most advanced missile defense systems face economic strain. This is where Iron Beam fundamentally changes the equation. Iron Beam was designed not just to intercept threats, but to reverse the cost-benefit imbalance entirely. Instead of launching missiles, the system uses directed energy, high-powered laser beams capable of heating and destroying targets in seconds. The cost per interception is estimated to be just a few dollars, primarily the cost of electricity. This transforms air defense from a financially draining necessity into a sustainable, long-term solution. What makes Iron Beam truly remarkable is not only its affordability, but its speed and precision. Lasers travel at the speed of light, meaning there is virtually no delay between detection and engagement. Once a target is locked, the beam remains focused on a precise point until the structure of the drone or rocket fails. There is no explosion, no debris raining down unpredictably, just a clean, controlled neutralization in midair. Iron Beam is not intended to replace existing systems like Iron Dome. Instead, it represents the next evolution in Israel's layered defense strategy. By handling low-cost, high-volume threats such as drones and mortars, Iron Beam reduces the burden on missile-based systems, allowing them to focus on more complex and dangerous targets. This layered approach strengthens Israel's overall defense posture and enhances its ability to sustain long-term security operations. At its core, Iron Beam is a directed energy weapon, a class of systems that use concentrated electromagnetic energy rather than physical projectiles. In this case, the weapon employs an advanced solid-state laser capable of generating extremely high power levels. When the system detects an incoming threat, advanced radar and tracking systems lock onto the target with extraordinary accuracy. Once locked, the laser focuses its energy onto a small, precise area of the target. Within seconds, the intense heat causes structural failure, metal weakens, electronics melt, fuel ignites, or the projectile simply disintegrates. The entire process occurs almost instantaneously, leaving no time for evasive maneuvers. One of the greatest advantages of laser-based defense is precision. Unlike interceptor missiles, which explode near their targets and can create falling debris, lasers offer a controlled method of neutralization. This significantly reduces collateral damage, a critical consideration when defending urban areas or civilian populations. However, laser weapons are not without challenges. Atmospheric conditions such as fog, smoke, rain, and dust can scatter laser energy, reducing effectiveness. To address this, Iron Beam incorporates adaptive optics and advanced beam control technologies that compensate for environmental interference. These innovations allow the system to maintain accuracy even in less than ideal conditions, making it viable for real-world combat scenarios rather than limited laboratory use. The success of Iron Beam demonstrates that directed energy weapons are no longer theoretical concepts confined to research labs. They are operational, combat-ready systems capable of reshaping modern warfare. The economics of warfare often receive less attention than tactics or technology, but they are just as critical. A defense system that cannot be sustained financially is ultimately vulnerable. Traditional interception systems, while effective, impose enormous costs during high-intensity conflict. When hundreds or thousands of rockets are launched, the financial burden can escalate rapidly. Iron Beam addresses this problem directly. With an estimated cost of just a few dollars per shot, the system allows Israel to defend against massive volumes of incoming threats without exhausting resources. This economic advantage fundamentally alters the strategic calculus for both defenders and attackers. For adversaries, launching large numbers of cheap rockets or drones becomes far less effective when those weapons can be neutralized almost instantly at minimal cost. The strategy of overwhelming defenses through volume loses its power. Over time, this could discourage such attacks altogether, reshaping patterns of conflict. This cost efficiency also makes Iron Beam highly attractive to other nations. Countries facing similar threats from drones, mortars, or short-range rockets may see laser-based defense as a practical, sustainable solution. As a result, Iron Beam could become a catalyst for widespread adoption of directed energy systems around the world. Iron Beam fits seamlessly into Israel's sophisticated layered defense architecture. At the highest level, systems like Arrow intercept long range ballistic missiles. David's sling handles range threats, while Iron Dome focuses on short-range rockets and artillery. Iron Beam now operates at the front line, targeting drones, mortars, and low-altitude threats before they reach other layers. This integration ensures that no single system bears the full weight of defense. Iron Beam handles the most numerous and least expensive threats, conserving interceptor missiles for situations where lasers may be less effective. The result is a more resilient, flexible, and sustainable defense network. Another advantage of Iron Beam is its potential mobility. Unlike large missile batteries, laser systems can be mounted on mobile platforms, allowing protection to shift as threats evolve. This flexibility enhances Israel's ability to defend borders, military bases, and critical infrastructure wherever needed. The development of Iron Beam is the result of more than a decade of research and innovation. Led primarily by Rafael Advanced Defense Systems in partnership with Israel's Ministry of Defense, the project faced numerous technical challenges. Early prototypes struggled with power generation, beam stability, and target tracking. Breakthroughs in solid-state laser technology, energy storage, and sensor integration eventually made the system viable. Achieving consistent beam stability over operational distances was a major milestone, as was integrating radar and electro-optical sensors capable of tracking fast, moving targets with extreme precision. Recent demonstrations confirm that Iron Beam has moved beyond the experimental stage. It is now a scalable, deployable system ready for integration into Israel's national defense strategy. Officials have already indicated that future upgrades could extend its range, increase power output, and further improve performance in adverse conditions. Globally, the implications of Iron Beam are profound. Drone warfare has rapidly expanded, allowing even small groups to conduct sophisticated attacks. Drone swarms, in particular, pose a serious challenge to traditional defenses. Iron Beam is uniquely suited to counter these threats, as it can fire repeatedly without reloading, limited only by available power. This capability has drawn intense interest from militaries worldwide. Nations across Europe, Asia, and the Middle East are closely monitoring Israel's progress. Some may pursue their own laser defense programs, potentially triggering a new arms race centered on directed energy weapons. While Iron Beam offers immense advantages, it is not without limitations. Environmental factors can affect performance, and current operational ranges are best suited for short-distance defense. Power supply remains a logistical consideration, particularly for mobile deployments. Most importantly, Iron Beam works best as part of a layered defense system rather than as a standalone solution. Despite these challenges, none are insurmountable. Like all military technologies, Iron Beam will continue to evolve. Just as Iron Dome improved dramatically over time, laser-based systems will become more powerful, more resilient, and more versatile. Strategically, Iron Beam sends a clear message. Israel is committed to maintaining technological superiority and adapting to the changing nature of warfare. For allies, particularly the United States, the system offers opportunities for collaboration and joint development. For adversaries, it represents a significant obstacle to traditional asymmetric tactics. Looking ahead, the future of laser-based defense appears increasingly certain. As power generation, optics, and targeting technologies advance, systems like Iron Beam may become as common as missile interceptors are today. Mobile platforms, naval installations, and even airborne laser defenses could soon become reality. Iron Beam stands as a symbol of innovation, resilience, and strategic foresight. It proves that even the most ambitious ideas, destroying rockets with beams of light, can become reality when necessity drives innovation. As the system continues to evolve, its impact will extend far beyond Israel's borders, shaping the future of warfare itself. The battlefield has changed, the rules have been rewritten, and the age of laser defense has officially begun.